Shall we start, guys? Or you still need more time? Okay, it seems that everybody's done. Okay, guys. So with regarding today, we'll be done with our last handout, and next class and the class after will be the group presentations. I'll send an announcement, but please take these notes as a kind of instruction. And since the beginning of the term, we said that the verbal class comments or instruction is part of this class curriculum. So the groups will be called randomly in the assigned date for each group. So your group could be the first group to present, the last group to present. Siwan, sorry, I cannot activate the transcript because, as you may know, that every time it's making us a problem. It will freeze the screen because of the long video time. So sorry, I cannot accept the request. So as I said, the groups will be called randomly. Attendance is mandatory. You have to switch on your camera while presenting. The classes and the presentation will be recorded, but it will not be posted on the YouTube channel. It will be kept for department and university audit only. The presentation mark will be divided into two parts. Part for group to evaluate the whole presentation, and part will be individual. So for example, if your colleague get 9 out of 10, you might get 10 out of 10, or you might get 6 out of 10. This depends on you. The second important point, every group member should be responsible to answer any question about their presentation. And what do I mean by attendance is mandatory? Attendance is mandatory for all students. There is a portion of the project mark to attend the presentation. And I know some students will just, especially for example, next week, 29th, if your presentation or your group presentation is on the 6th, you will join the class before the time and you left, you keep your computer on and you show that you are attending an OWL. However, you are not there. And every class I see this. When I'm done with the class, those students who are attending, listening, once we're done with the class, they leave the meeting. And every class I have 4 or 5 students, I call them by name, they don't respond. So be ready also to ask you about one of the presentation, any question. And it will be randomly. You could be called 2 times, 3 times, you could not be called. And this would be part of your personal presentation mark. I'm not harsh, guys, but you have to show respect to your colleagues and to other groups. all of you spend efforts in preparing your presentation, your project. So these efforts should not but just be appreciated by myself or the TA for the marking purposes. It also should be appreciated by your colleagues, because you will learn something from any presentation. And it's part of the curriculum. Some of the topic and the learning outcome are covered by the presentation and the group project. Now, some of you guys asking, what is the format? What is the length of the project? What is the length of the presentation? We have 6 groups to present next week and other 6 groups to present the week after. Each group will have 20 minutes to present. So design your presentation to cover the topic and to distribute certain number of slides and time slots for each one equally in your group. And we'll have after 5 minutes for questions. So try to make your presentation or the whole group presentation maximum 20 minutes, 15 to 20 minutes. This is the time allowed. And then we'll have 5 minutes for questions. Now, how you divide it? It depends how you divide. You'll divide your report: introduction, literature background. If you don't have it, if it's analytical or implementation, this is how our project is done. This is the methodology. This is piece of code. This is the output. This is the result we achieved. And for those who implemented some code, you have to show or to run, to like assign 4 to 5 minutes to demonstrate your software, how it's working, or your program, how it's working. Clear about the presentation? Any question? Don't hesitate to ask. Again, guys, any question about the presentation, how you will organize your group yourself, how the thing will go? Is that clear? I would assume that since there is no student ask, that it's clear. Now, regarding the report, there is no like a specific length for a report. I'm not asking you to write a research paper to give you like a certain length. Since you fulfilled and satisfied your project, I'm okay with that. So it could be like 7, 8 pages, 12 pages. Depend, maybe more, maybe less. Since now for the format, it's Times New Roman 12. Citation should follow IEEE standards, same as a proposal. I will send those again. Now, there is a cover page, and there is a last page in the report that each group member contribution. Like, for example, X, write the introduction, do this, design the presentation, whatever the task assigned for each individual group member. If he did none, I know that there are some names, some of them, they drop the course. Some of them, I don't know, they attend the quiz 1, assignment 1, and they didn't show up again, even in the midterm or quiz 2. I don't know what's going wrong with them. I hope that they are safe and good, in good situation. But this has happened. So if your group member did not contribute, don't hesitate to write that in the report. Last page of the report, after the references. Each member contribution. The first page should contain the title of your project, your group number, your name, and student ID. And in the top, the course number, ECE 9013A, programming for engineers, the course name. Then project title, I will send all of those in an announcement with attachment. So please be careful that your writing is original. You have a proper citation using IEEE format, and plagiarism or Turnitin will be used to this one. Any question about the project? Any question about the project, guys? If not, I'll move to assignment 2 and 3. Okay, looking there's no questions. Now, for assignment 2, I said that many times in the class that in assignment 1, high plagiarism was detected. We give like small penalty for those who has or who have few students who have high plagiarism ratio, and we know most of them, they are from University of Western Ontario, and we know that this code was submitted by X student last year or the year before. So Turnitin, give us even the name that you took their solutions. In the course outline, in the first class, we mentioned that this is an academic offense based on Western regulations and academic integrity model. And I said, don't do this in assignment 2. However, I found more students did that in assignment 2. Guys, I don't want to report any student to the dean. You know what is the rule saying? It could be reached to be out of the program. Why you put yourself in this situation? It's simple assignment. Even you copy the notes of your colleague that you took their answer for last year course. And by the way, even if he is graduated, Western can follow him. Why he did that and give you his answer or her answers for the same course and same assignment? You are a graduate student, guys. I'm talking for those who did that. The majority that they have their original solutions. So this is the last warning. I'll ask the TA in marking assignment 2, but don't blame us if you have high penalty this time. Don't blame us if you have a high penalty this time. I'm still lenient with the student because I don't want it to affect any student negatively. But if you are a graduate student, so this is the last warning, guys. I should do this based on the regulation. I have to report even in assignment 1. But I said, no, they are new to this. Let's warn them. But it seems, and I give a warning during the class before submitting assignment 2. Even last week I said that, but it seems, I don't know. We have more students did that. Some of them 70% plagiarism from a submitted University of Western Ontario assignment last year and the year before. Come on, guys. So this time I'll ask the TA to give a harder penalty by mark deduction for those. Anyone who has plagiarism more than 45%, and we go inside and see how the plagiarism, if it's a code, a line, I'll forget it. So we'll go in deep details inside the document. But those with high plagiarism, you will get 0 for each question. You have a high plagiarism ratio. this time. If it's happened again in assignment 3, I'll report it to the dean and I'll follow the rules. Don't blame me, guys. I said I will do this with assignment 2 last class, if you remember. But I'll give another one more chance. Don't do it in assignment 3. Again, don't do it in assignment 3 or in the project report. It will be checked by these softwares. Code similarity check and turn it in. If this happens, some students, they have 0%. How I can give you the full mark for a question you copied it from your colleague, and this student who did that, who spent time and efforts to solve assignment by himself, how I can give you the same mark, guys? Is it fair? I'm sure you answer no. Look at his answer. I don't mind. A lot of questions, the answer available on the internet. Look at it, understand it, and do your own code. Don't copy and paste. Don't be lazy to take your other work. So guys, don't blame me in assignment 3 and in the project if I take a formal action with the department and the dean office. This is a last warning. Last time I said it's a last warning, but I'll give another chance. Next time, no more chances. Don't blame me, guys. I'm trying to be at your side to the maximum. But don't understand it that in the way that, no, he will not do anything. No, I will do. I'm not willing to do. Help me to help you. Do your job, and you'll see my appreciation through marks. But if you keep doing the same, then you will be reported. Don't blame me. Clear, guys? Any question? And don't send me an email that I can swear it's my original work. How come? If it's your original work, turn it in. He don't know you. He don't have any problem with you to say that there is 75% or 60% or 50%. University of Western Ontario by law, it's a 20% to 25 maximum. I'm giving you 30, guys. From the beginning of the course, I give you more. But to reach above 40 and 50, some students 75 and 65. Come on. So work professionally. You are a graduate student with your certificate MEng. You will be graduated. Even if you start with junior position, within 1, 2, 3 years, you will be in a senior position. Do you accept the group of people you are working with to cheat you or not to do their job properly? No, you'll not accept. So try to do your job professionally. And I'm saying again about those who did this. Most of you know. Thank you, guys. You did very well. Questions before we start with last handout? Okay. So we will start with last handout. In this course, can you see the presentation?
Yes.
Okay. Thank you. So we touch base with these algorithm and we talk about them. Some of you will see those algorithm again with some projects. in the next 2 weeks. However, we will touch base with this algorithm this week because they are very important data structures. So searching and sorting algorithms. Searching algorithm, it's a method for finding an item or a group of items which is specific with specific properties within a collection of items. I'm looking for a student in a student list. I'm looking for an item in a grocery store. I'm looking for a doctor in a hospital. I'm looking for a patient name. I'm looking for a lab results. I'm looking for a paper in a paper database, a research paper. I'm looking for a book. So we will use searching algorithm. So collection could be implicit. So find the square root as a search problem. Exhaustive, bisection search in Newton, Raphson. Collection could be explicit. Example, is a student record in a stored collection of data? You are working in a registration department in a university and you receive, can you please send us a record of A or X student? So is it stored or not? We have to find a searching algorithm. So the first searching algorithm and one of the simplest implementation of searching algorithm is a linear search. I start at the beginning of the search till the end of the search. So brute force search, or what is called AKA British Museum algorithm, list does not have to be sorted. So in linear search, the list I'm searching on it does not have to be sorted. Bisection search, we talk about this kind of search, so the list must be sorted because I check the value if it is above or below. So if it's below, I will search on the first part of the list, first half of the list. If it's greater, then I will search in the second half of the list. Then I will divide it into another 2 parts. Then I'll go till I find the item or return null. So 2 different implementation of this algorithm. We saw it in the previous classes. Linear search on unsorted list. Recap. We talk also about linear search at the beginning of the course. So we define a linear search and we send it the L and E found equal false for I in range of length of L. If E equal Li found it true, return found. So we use true to speed up a little bit of the implementation. However, this will not impact the big O in worst case scenario. Must look through all elements to decide it is not there. Big O to len of L for the loop, which is big O of 1 to test if E is in LAI. Overall complexity is big O to N, where N is the length of L. Assume we can retrieve element on the list in constant time. So it has the big O of N for linear search. Now, if it is in sorted list, how we will implement it? If we know that the list is already sorted. For I in range len, if L of I equal E, then return it true. If L of I greater than E, return false. Must look and to reach a number greater than E. For example, if we are talking about ID, like that end in 56, and we know it's in a sorted list, and I'm looking for a student that like their student ID, it's only 2 digits, 56. So, and I know it's assorted, then I'll work till I reach to 56. If I reach to a number greater than 56, their ID, then that the student is not on this list. So I can stop at that point. But again, it will be with a complexity of big O of n, where n is equal the length of that list. Bisection search will pick an index I that divide the list into halves, ask if L of I equal E. If not, ask if L of I is greater or smaller, depending on the answer, searching left or right half of L for E. A new version of divide and conquer algorithm, break the other halves to new halves, then do the same. So we are dividing the list to a smaller piece to make the search process easier. This is the implementation. So based on the evaluation of this, the complexity will be big O of log n, big O of log n. So if we are searching a sorted list, using linear search for an element is O of n. If we use a binary search, it can be, or bisection search, it could be for an element of big O for log n. Assume the list is sorted. When does it make sense to sort first, then search? Sort, which is plus big O of log n less than big O of n. So sort is less than big O of n minus big O of log n, where sorting is less than big O of n. Never true. To sort a collection of n elements must look at each one at least once. So here is saying that if I have an unsorted list, shall I use binary search? If I want to use a binary search, it must be sorted. So is that a suitable solution or not? So why bother sorting first? In some cases, may sort a list once, then do many searches. So this is depend. Is the sort when it will be beneficial? If I'm doing multiple search, then I can sort it once, then I can do multiple search. So this is what we call it amortized cost of the sort over many searches. So sort plus k times big O of log n less than k of big O of n. For large case, sort time becomes irrelevant if cost of sorting is small enough. And we said from the previous two handouts that the big O of n, we make it generic, but this depends on the time, on the machine, on the number. So many factors will let us decide. So sort algorithms want to efficiently sort a list of interest, typically numbers. We'll see a range of methods, including one that is quite efficient. So monkey sort, aka bogo sort, stupid sort, slow sort, permutation sort, shotgun sort. To sort a deck of cards, throw them in the air, pick them up. Are they sorted? Repeat if not sorted. We call this monkey sort. Complexity of BOGO sort. Diff BOGO sort while not is sorted L random.shovel L. Best case big O where n is length of L to check if it's sorted. And at that time I'll find it sorted. Worst case big O of unknown. If really unlucky, every time I check and it's not sorted. The second one, and one of the common sorting algorithm, we call it bubble sort. Compare consecutive pairs of element, swap element in pairs such that smaller is first. When reach end of the list, start over again. Stop when there is no more swap to be done. Largest unsorted element always at end after pass, so at most and pass. So you can go to the Wikimedia to find the bubble sort animation. So this is the source of this figure. How I do it? Swap equal false, while not, swap equal true. For j in range of 1 to length of L, if this element is greater than that one, do swap. We will repeat till there is no swap. Inner for loop is doing comparison, and at that time, since we have a double time or a double loop, then it will take big O of n square, which is not easy, which is a high complexity. Another sorting algorithm, we call it selection sort. First step, extract minimum element. Swap it with element at index 0. Subsequent step, in remaining sublist, extract minimum element and add it with the element at index 1, and so until I end the list. Keep the left portion of the list sorted. At ith step, first I element in the list are sorted. All other elements are bigger than the first I elements. Analyzing selection sort, loop invariant, giving a prefix of list 0i and suffix I plus 1, length of I, then a prefix is sorted and no element in a prefix is larger than the smallest element in suffix. Base case, prefix empty, suffix whole list, invariant true. Induction step, move minimum element from suffix to end of a prefix, since invariant true before move, prefix sorted after append, when exit prefix. So this we call it like the algorithm English like wording. Prefix is entire list, suffix empty, so sorted. In this one, guys, what we will do of selection search, we will move the minimum item in the list to the first position. Once I fill index I0, then I'll move to I1 and put the next smallest element till I find a sorted, or I have a sorted list. Outer loop will be executed and maximum for the length, which is n, the inner loop for n. So again, so it's like the bubble sort, so it has a big O of n square. Merge sort, use a divide and conquer approach. If the list is of length 0 or 1, already sorted. If the list has more than one element, split into two lists and sort each. Merge sorted sublist, look at first element of each, move smaller to end of the result. When one list is empty, just copy rest out the rest of other list. So this is the merging sort. This is unsorted and this is unsorted. I'll divide it into halves, then I'll divide it into halves, then I'll divide it into halves till I sort each two elements, then I'll merge it. Split list in a half until I have a sublist only have one element. Okay, so this is, we call it divide and conquer. Then we'll back till we have a sorted list. But so for example, I'll have this list, left in list 1, left in list 2, compare result 1, 2 till I reach to the sorted one. Merging sublist step, these are the code for merging sublist step, left and right sublist till we done. So the complexity, go through two lists, only one pass, compare only smallest element in each sublist. So it's big O to the len of left plus len of right, copied elements, big O of len, longer list comparison, linear in length of the lists. We'll continue back, divide the list successfully into halves. Depth first, such that conquer smallest pieces down one branch first before moving to the larger pieces. This is an example of the list, how we will divide it. So the complexity of a first recursion level, it's big O of n and big O of n, which is big O of n. The second recursion is big O of n. Divide list into half, it will be O of big O, and overall complexity is big O of n log n, where n is the length of L. So with a small n, it is acceptable and it's better than big O of n square. Sorting summary: BOGO source, randomness unbounded, bubble sort big O of n square, selection sort big O of n square, merge sort n log n is the fastest a sort can be. So this is the best one, which is the merging sort. So what we have seen in this course: the data structure, iteration and recursion, abstraction, organize and modularization with the object-oriented, and different classes of algorithms, searching, sorting, and complexity of algorithms. Learn computational models of thinking, begin to master the art of computational, make a computers do what you want them to do. So hope we have started you down the path to being able to think and act like a computer scientist. So guys, this course is the first step in programming. You want a more skill to be a professional programmer, you have to go for further level, but we put your leg on the path, on the right path at the first step of the programming ladder. What do computer scientists do? They think computationally, abstraction, algorithm, automated execution. Just like the threes, reading, writing, and arithmetic. Computational thinking is becoming a fundamental skill that every well-educated person will need. The 3 A's of a computational thinking: abstraction, automation, and algorithms. What is the aspect of computational thinking? How difficult is the program and how best can I solve it? Thinking recursively sometimes. It would help. Thank you, guys. I wish that you got the benefit that we require from this course. Again, in the next 2 weeks, we will see in the project whatever we learned in this course. You have to use function, you have to use classes, you have to use whatever, and some of other presentation will talk about complexity, searching, and sorting algorithms. So even the project will cover again or do like a comprehensive revision of what we done since the beginning of course till today. Questions? If you are okay, you don't have a question, the project presentation, the project report instruction are clear, you are free to leave. Tomorrow, I will send an announcement, including these verbal instruction I mentioned today about the project. So have a good day and you are free to leave. Thank you, Wester.
Thank you, Professor.
Yeah, thank you, Jocelyn. Thank you, Ahmed.
Thank you, Professor.
Thank you, thank you. Thank you, Fiona. Thank you, Muhammad. Thank you, Vinit. Thank you, Hauhan. Thank you, Ajit.
Oh, it's 5:30 only.
What? Thank you, Fatmir. Ahmad Jamal, do you have any question?
No, sir. Thank you so much.
Thank you. Sir, do you have any question?
Hi, yes, Professor, I have a question.
Okay, go ahead.
During this project, we're doing coding tasks separately, then we'll come together. And there's an issue where a code was done, like a program was run on one computer, everything worked. But the person who was integrating our code, when the code was sent to him, he couldn't get the modules required. So is there a way that we can sort such an issue out if the systems are different and modules can be installed on one computer but won't work on another computer?
You should, guys, from the beginning, I told you should agree to work on the same platform. So the code will be compatible with each other parts.
It's the same platform, is still Windows.
No, I'm talking like if you use a Jupyter, if you use like C shell, if you're using normal Python. So I don't know which compiler you are using. So there is a lot of different version of Python, so it should be the same. And might be an issue with your colleagues who are combining the modules together that is not install the libraries that is required. So you have to check what are the errors. If it's installing of libraries, he should like pip install these required libraries. So the code will work, should work.
So
or if there is different naming, of the object classes, variables, it should be unified.
Okay, great, thank you.
So guys, you have to sit together. Each one who design like this piece of code, what are the problem? And you can see the error coming. What is the error? Then most probably it's a library issues. Importing libraries. So maybe you install a library that he doesn't have, so your code will not work at his machine.
Okay, Professor. Thank you.
You are welcome. Janwi, Qkong, Yutina, Jianli. Do you have any questions, guys?
Hi, Professor.
Hi.
I want to ask about my assignment one. It said similarity detected, but I do the assignment by myself. I don't know why it happened.
Okay, send me an email and I will check your reports.
Okay, thank you, Professor.
You are welcome. You are welcome. Okay, guys, do you have any question or shall I end the meeting? I'll end the meeting in 30 seconds. If there is no more question. Do you have any more question?
No, Professor.
Okay, have a good day. Okay, I would assume that there's no more questions, so I will end the meeting now.